Okay, we understand about what is the Hadoop. Hadoop is one of the framework that allow for a uh, distributed data processing. It's for the predictive analytical activities. It's a data science field. So Doc Cutting is the person who developed the software in the year of 2005. When he's working in Yahoo company, he started search engine problem solving search engine problems. Google also facing same kind of search engine problem, and Yahoo also same search engine problem. So he found the solution from taken the white paper from the Google company for the MapReduce and the Google file system. He converted into a Hadoop distributed file system. That's a HDFS. That is major software for right now we are using. Okay. So Hadoop is based on the work done by the Google in 1990s, early 2000. It's basically Google file system published in the year of 2003, and MapReduce is subsequently published in the year of 2004. So this big data field, Hadoop field, has been started in the year of 2005 only. So last 10 years, 10 to 16 years only, this particular big data field into picture into our IT industry. So majorly to say is 2007. So last 10 years only, currently 2007, 7 to 7 only, 2007 to 17 only, 10 years of data growth is happened so far in the big data field. Still there are a long way to go. There are more and far and advanced topics are coming. Okay. So first what you have to understand in this Hadoop is one of the major concepts called MapReduce. Okay, we discussed about how to process the data into Google file system. It's into 64 MBs of data block. MapReduce is the key comma value per concept, where each block will be identified with the key, and the value will be what inside into the block. So one block will be compared with the another block. Based on that, there it will apply your business logic. That business logic will be slices into business logic, whether it matches the condition within the two blocks. It won't process for entire terabytes data. Okay, it will process between 164 block size to another 64 block. When it is comparing, when it is matching to that particular key comma value and then the key comma value pair of the other data block, then it will take that block for data processing. If it is not having that particular data block, it is not containing that particular value of business article, it will ignore that data block. It will remove the data block from the processing. Okay, reducer is different concept. Remover is different concept. The remover will be removing from the data packet from the data processing. Reducer is the combining your result set. Okay. So when it's loading the data, it will be split into multiple blocks. Typically it is 64 MBs of data block, but it can also change to 128 or 256 MBs of data block. The master program allocate the node. So there is a different node concept you have to understand. It's called data node. There's two systems you have to understand in the Hadoop components. One is the Hadoop distributed file system, and second is the MapReduce. Hadoop distributed file system is one of the major concept of distributed environment. Okay, each system, this framework, this system will allow you 64 MBs of block size storage. When you are having the hard disk, that file, when you copy the hard disk file into the HDFS, the HDFS is a logical layer of your hard disk. On top of your hard disk, there's a logical layer will be created of HDFS. There you can, okay, again the connection is lost. Let me double check that. Is it my voice is audible? Are you able to see my screen? Hello, are you able to listen the words? Hello, is it the audio is back?
Able to hear now.
Yeah, fine. So now my internet connection has been back. I have two internet connections. So if one is down, I'll just switch over to the another internet connection. So no need to worry. So if it is anything is blocking, have the alternate backup. So I just reconnect over that. Okay, fine. So let's move on to what is the topic we're discussing about the Hadoop. In the Hadoop, there is a, so before to go into this slide, where we stopped previously, where it's got disconnected. Are we disconnected on this particular slide or in the map reduce slide?
Map reduce slide.
Okay, map reduce slide. So everyone understand the concept of map reduce, right? It is a key comma value per concept. Any doubt on this map reduce? Because this map reduce is a very important concept to proceed further. Anyone has any doubt on this particular map reduce slide?
Can you repeat once again, Mani?
Okay.
The map reduce concept.
Sure.
Thank you lots.
Okay, so this particular Hadoop is the one of the software tool where you can able to process the large data sets. It can able to process terabytes of terabytes. If you are consider Google search engine, for example, I'm going to the Google. If I'm putting what is big data, okay, if I'm typing this big data, okay, if I'm typing that, it is producing the certain numbers of result within a millisecond of time, 0.81 second. It is processing multiple data packets and then it is producing the result set over here. Okay, and the same thing if I'm just putting over here into the yahoo.com. Okay, so here typing what is big data. Both are same keyword, both are search engine. It is producing 25 crores of data result in 0.5 second. And here this big data is produced over here. How much is the data? 84 lakhs or crores. 8 crores 40,000. 8 crores 40 lakhs. Okay, here 25 crores. 2 crores 50,000. 1 second. 25 crores. Okay, so this is a difference of result set where it is going to process in a very faster time, right? 0.54 second it is getting processed. How it has been getting processed? These servers are maintaining large data sets. Okay, from the large data set, it is processing 64 MBs of data packet. Each data packet will have one key and one value. This value will be inside your what is your data packet is the value. For each key will be an identifier. There is a master and slave concept in the big data. The master node, what it will do, it will create a name for the data packet. The only job is to master node is creating a data name for key name for a data packet, and then it will transfer to a client machine. The client server concept, the server will the client will request and server will process. But in the master and slave concept, server will request to the client, multiple client in a distributed environment, it will process and it will return back the result to the server. That's a totally different concept. Previously, so for last 20 years, we use the client server concept. Client will request and server will respond. And now we are using the reverse. Server will request and client will respond. That's a concept called big data. So if you are considering your IT company, there are thousands of employees there. Okay, when thousands of employees there, where each employee will have unique identification number like employee ID. Similar way, if you slice the 1 terabyte of data packet, it will produce the multiple 64 MBs of data packet, right? So when it is coming to the multiple data packet, each data block is 64 MB. Each data block will have a unique identifier number. It's called key value. The value, the key, it's a key. It's not a value. It is a key. Inside the data packet, 64 MB is a value. So one data packet of 64 MB block will be compared with the another data block. So both will be compared. Here only it will apply your business logic. If business logic is matches between these two data packet, then it will process for your next stage. If it is not matching, it will ignore for data processing. It will not process entire 1 terabyte. It will process where your data packets are matching. So that's why it is very faster. Okay. So any doubt on this map reduce? Anyone has any
matches
question?
will happen parallel, right?
Come again?
Yeah, it's matches, right? It's happen parallel, right?
It's like a parallel. What it will do, it is a distributed way. So what it will be, the concept here is, I have 10 computer. Okay, if I have the 10 computer, these 64 MB blocks are stored into three times into multiple computer. Okay, it can be the Hadoop system will decide, Hadoop algorithm will decide, or I have to process on which computer during the execution time. I need to process on which computer, where I need to keep this data packet, either in the computer 1 or computer 2 or computer 5. When I am executing next time, it can be computer 3 or computer 5 or computer 7. That's a different logic the algorithm will work. The second thing is whether it's parallelly working. Yes, it will parallelly working when the computer data packet is processing on one data packet in the one computer 1. Similar way, computer packet 5 and 6 may be working on the another computer. That's a multi-cluster. It will parallelly execute, parallelly compare with the 5 data sets in the computer 2, 2 data set in the computer 1, 5 data set in the computer 3. Likewise, it will compare within the data packet. It will be split and multiple way it is split, and then it will compare. One computer is producing certain result set from the computer 1. Computer 2 is producing certain results from the computer 2. These result sets are reduced, and then it will combine, sort, shuffle, all the things it will process. Then it will produce your result set from the computer 1, computer 2, computer 3. Likewise, how many computer connecting, each computer will produce the result set. So from the result set, it will do the combining of all the stuff. Then it will go back to the server master. It will produce the result.
Okay.
Anyone has any other question? So two things we have to understand on the Hadoop. One is the Hadoop distributed file system. That's a major component in the Hadoop. There only we are storing and retrieving the all the 64 MB of data packet. And second one is the map reduce concept. So under the map reduce only, all the program will execute. Like if you are writing the pig script, poop script, HBase, Hive, map reduce program, anything, even if you write the Java program, that will be converted into the map reduce program. Or pig if you are writing, HBase you are writing a script as like SQL server, Hive you are writing the SQL server kind of coding. Then all the codings will be converted into the MapReduce program. Then when it will execute, the compiler will convert this coding into a MapReduce format. Then only it will process your this two layer. This two layer is very, very important. So before that, I want to go to one more slide. I'll just show you that. Okay. So this is a slide, is very important slide. So we studied about the what is the HDFS. HDFS is the Hadoop distributed file system. And second one is the map reduce, right? These two concepts we studied. HDFS will store the 64 MB of data packet, and map reduce will store into key comma value pair concept of it will process your data. But how if you are connecting 10 different computer, how to manage these resources like a hard disk capacity, RAM capacity, or the system whether it is running or not. So for that, in 1.0 there are small components that are already present in the this map reduce or HDFS layer. But in HDFC Hadoop 2.0 they created into another layer called Yarn, yet another resource navigator. So that particular navigator will work you for its negotiator where it will perform for your resource management tool. Okay, that will manage your RAM, computer, which computer need to get processed, whether computer is live or not. So every computer, if you are connected 10 computer into the master and slave concept, the master and slave, between the master and slave, every 30 millisecond, there is a heartbeat will come. Okay, there is a heartbeat will come. Okay, there is a heartbeat will come. From that heartbeat, it will check that, okay, still that system is live or not, whether still it is processing or not. If it is not coming that response from the client, that is 30 milliseconds, then it will ignore that particular computer. Whatever the data packet is available, there is a 3 replication available on the same different computer, right? The same data packet will be in 3 different computers also. Because if any computer's failure is happened, from the failure, it need to be continue the process, because we are processing very large data, right? There should be no failure should be happen on your data processing. So that's why Hadoop by default is storing 3 replications of your data packet for processing. So then the MapReduce, then other tools is the Hadoop 2.0. Hadoop 3.0 also now comes into the picture. So let's understand certain other topic called what is a name node, what is a master node. Those things are very important concept. Okay, so let's understand about this MapReduce. We understand the MapReduce. So if you are processing 1 terabytes of file, you are giving the input file chunk, it is split into multiple chunks, and there is a mapper will be automatically mapped, and then we no need to do any program for that. I'm telling about this internal process, how things are working, the MapReduce. For writing a program, you have to write only your business logic, where to read your data packet, what is the business logic you have to apply, and what is the result you want to come. So that is the business logic only you have to apply for this MapReduce program. Inside the computer, how is MapReduce is working is, inside the any data packet is processing, it will map the value and it will process, internally it will sort, shuffle, combine, reduce, all these things you will perform for your data operation. Okay. So next concept is the Hadoop subprojects. Okay. Hadoop subproject, we have the first 2 layers called Hadoop distributed file system called HDFS, and Hadoop distributed process is called MapReduce. After the MapReduce, you have the other tools called Pig, Hive, Scoop, Oozy, Mathod, all HBase. These are the different tool is used for different purpose. Okay, there are 40 different tools, 40 to 60 different tools are available into this particular Hadoop environment. Okay, each tool is for its own unique purpose. If it doesn't know the Java, I don't know the Java, can I able to do the program with the big data? I know only .NET, or I know only I don't know any language. I'm very new to this particular big data. Can I learn this? Yes, you can learn this. You don't need to have the Java knowledge. If Java knowledge is there, it is added advantages. And if you doesn't know the Java languages, you can still do the programming using the Pig, Hive, HBase. All other softwares are available for your non-Java programmers. Okay, so Java language is there. It's a required if for advanced level people, advanced level programming. But still, if you doesn't know the Java, still you can use this big data field for intermediate level of programming language. So meanwhile, you can learn the Java also for that. Java or Python. Both the things are you can use very well over there into the big data field. So first thing is you have to understand this Hadoop ecosystem. The grouping of all the tools called Pig, Hive, Scoop are called ecosystem. So it has more than 30 plus different tools are available. So Hadoop distributed file system we discussed already. It's a 64 MB of block size or 120 MB of block size. It will be stored and retrieved for your logical layer on top of your hard disk. So the other thing is we have to understand called name node, data block. So that is very important. So we'll understand about that. Since it is the data processing unit, in the HDFS layer, you can able to write once and you can read many times. It is not like a database. You can keep on update. You can you can dump the data for one time and then you can read many times. Okay, so that's called Hadoop storage. Write once, read many times. So these files are split into each block size usually 64 or 120 MB of block size. So next thing is you have to understand main concept called master node. Okay, we have understand the client server concept. Server will be there, client will be there. Here in the big data field, there is a master will be there, and then client node will be there, slave nodes. The master node or name node, we can call it as a name node, where each data packet is giving a name, right? That's why it's called name node. The master node, what is the first duty is, it need to create a name for each data packet. Whenever the data is split into multiple small chunks of 64 MB data packet, it need to give a name, key value for that particular data block. That is the only job. Once the name is created, it will transfer that particular data packet to the one particular computer, client node or slave node to process. Okay, so it is also maintain a registry. Okay, because if 1 TB is split into multiple 64, there will be thousands of 64 MB block size will be there, right? It will maintain a registry. Which data packet I given to which computer is processing which computer data packet, where the computers get failure, which data packet is not processed. Everything will be maintained in a history or a registry that's called metadata. So two things you have to understand here from here. It's called name node, and one other thing is metadata. Okay. So next one you have to understand called data node. So the data node is the one of the major component where you can able to understand each 64 MB block size is called data node. Okay. The each block size will be called 64 MB of block size. If you have a text file, if you have a database file, if you have any raw file or video file, each file will be, if you have 1 GB of one file is 1 GB, that will be split into multiple 64 MB of block, and then it will be kept into processing into different computer. So that's called data node. The data packet is called data node. Another thing is called secondary name node. So that is secondary name node is taking care of the housekeeping tasks. Okay, if any other task need to be done through the master node, the secondary name node will be made in a housekeeping task node. If data node is failure, it will directly go to the another data packet, right? Another data node. But if master node is failure, that's overall failure. You cannot able to process anymore. Okay, so that is advisable to have a master node in a little higher configuration. All the slave node is the normal commercial computer. So because of data will not be go failure anytime. So this is the data node format where you can able to understand different 6 computer as block 001 is a 164 MB block. That same has been replicated in the block computer 4 and then computer 3. So computer 5 and then computer 3. So here you can find that BLK 001, 3 replication is there in the computer 3 and then computer 5. So totally 6 block, 6 computer. So here that particular block is been stored into multiple replication. Same data will be processed. If computer 1 is failure, then it will be automatically redirected to computer 3 or computer 5. The computer will decide, the algorithm will decide. That's why the framework will decide which data packet if failure is happen and take, or which data packet if I complete in the computer 1, what I need to send the result set. So those things will be decided by the Hadoop algorithm will decide over when it's processing. Two things you have to understand: one is a master node, another is a data node. Master node, which is the just specifically creating the name for the particular data node, and it will maintain a registry. The data node is the 64 MB of data packet. Okay, let's try to do some kind of hands-on session for today's first level of understanding about some Hadoop file system concept. Let me try to open that. Okay. So this particular it's a cloud lab, so where you can able to find the all the tools where you can able to it's organized in the manner of to what are the various tools are available. It's a pre-installed Hadoop environment. Are you able to see my screen? Is it my voice is audible?
Yes.
Okay. So I'm just showcasing the because many people asking me certain kind of demo or maybe hands-on kind of way. Normally, in the full-fledged training program, we will provide the all the hands-on. But I'll just tell about the what are the various tools so that you'll understand the environment on this particular way of how it's working. So this is a cloud lab. So similar way, we'll install on your laptop also. So all the tools will be get installed, and then you can work on the HBase, Hive, Pick the Scoop, Uzi, Zookeeper, Strobe, Scala, Kafka, Spark, Mathot. All the tools are available. So you can work whatever the tools you want to work. So to understand about the data node, so this is a data node. So this Ambar is a monitoring tool. Okay, this Ambar is a monitoring tool where you can able to understand this Hadoop distributed file system, HDFS. You can see the what is the data packet is running over here. Okay, here the how many data nodes are specific. What is the name node? Okay, what are the name nodes are running currently? So those things you can able to monitor. Okay, so here it has the multiple data node data packets are available. The map reduce which when you are running the map reduce what is the things are running. All these things are you can able to see the historical way of records over here. So this is a graphical user interface of what is happening on the monitoring. But normally we will work under the this particular cloud environment, right? Hadoop. We have to just type the command called Hadoop. When you type the Hadoop, you'll get a list of commands where you can able to find that the FS command, Hadoop FS is the first level file system. So if you want to create a formatting the FS, you can format the hard disk. How we are formatting like this? You can format the first time on your data packet, the HDFS layer. Then you can store whatever the dumping the data you can do. Okay, you can see some of the basic commands over here. Hadoop file system -ls, right? So this is ls is the list. Okay, -ls/input. It will show you the what are the files or home directories are available on your particular structure of your directory. Okay, so but this one what I'm showcasing here is the Ambari tool. When I'm processing the data packet, it is the completely monitoring tool where how many data nodes are splitted, what are the data nodes are going, so which data nodes are failure, processed, all these things we can able to get over there here. So you can check everything over here. Okay, if anything you are running over there, Scoop or Mathot or Spark and Scala, everything you can able to understand what are the clients are running, how many clients are running over here. If you are connecting, you can create a new computer also. You can create IP address of that particular computer. It's called a multi-cluster environment. Okay, it's called multi-cluster. So you can when you are installing on your laptop, it is a single cluster environment. When you are installing on this kind of cloud environment or in your if you're connecting multiple computer, you can create a multiple multi-cluster environment. Okay, so that's where you can when you're running the program over here. When you're running a program over here, you can able to understand the difference between a single cluster and multi clusters. Okay, so this environment where you can able to do that. So what are the tools we have to understand? This is a first level tool we can understand. One second, let me go through that. Okay, can someone read this particular list of tools? I just unmute everyone. Somebody read this tool? So these are the major tools we normally use on our training or the programming. If you want to become a Hadoop developer, can someone read what are the list of tools? It is under the left side. I'll explain you what are the tools. Someone can you read that tool, list of tools, what we have?
HDFS, MapReduce, Yarn, Hive, HBase Pig, Scoop,
HBase.
Uzi,
Uzi.
Zookeeper,
Okay.
and the next one I'm not sure, Storm I believe,
Storm.
and Flume,
Flume.
and after Flume it is Accumulo,
Below.
and
Ambari.
then it is Ambari Metrics,
Okay.
then Kafka,
Kafka.
Nox, Maho,
Nox.
and last one is Slider and Spark.
Okay. So why? Because I have asked you to read some people to read, because each word will be a different terms of English language. Okay. Each and every word pronunciation is totally different over here in the big data field. So I'll tell you about this HDFS. HDFS is the Hadoop Distributed File System. Okay, we have to call it as a HDFS, Hadoop Distributed File System. And second one is MapReduce. MapReduce 2. Why it is called MapReduce 2? Because it is the second version. So one second, I'm getting one call. Okay, it's disconnected. Okay, we are understanding about the HDFS and then MapReduce 2. MapReduce 2 is the second version of your Hadoop. That's why the MapReduce 1, it's the first version 1. MapReduce 2 is the version 2. MapReduce 2, that's the engine. MapReduce 2 engine. And third one is the Yarn. Yarn is used for managing the entire resources. Okay. The other thing is called Test is there. Test is also one of the two. Hive is there. Whatever the green color, we will talk about that first. Hive is the one of the tool where you can able to process on similar to our SQL server. Okay, similar to our SQL server. What are the commands we use? The select star from employee table. Similar way you can use the HBase or Hive. Hive is one of the SQL server based kind of tool, language tool in the Hadoop environment. HBase is the horizontal oriented database management tool. It will process column oriented data. It will store and retrieve the data into column oriented fashion. It's a different kind of fashion where you can able to process terabytes of data storage into your HBase, and then you can directly point to your data packets. Okay. And Peak is the another tool. It's a normal English language tool where you can able to write a program. Many scientists will use this tool for writing the data structure oriented tools or unstructured data type or semi-structured data based kind of way. They will use this particular Peak tool for a normal English language. Okay, if you want to load the data, just specify the load file name. Then use a Scoop is another tool for importing and exporting the databases. Then Uzi is the workflow tool, where how this workflow need to be happen for this project. Scheduling tool. And Zookeeper is one of the major tool for managing the entire infrastructure, entire databases or entire servers, clusters to manage the administrative tool. If you want to become a Hadoop administrator, you should need to understand this tool end to end of Zookeeper. Then Falcon is the another tool, and Stroom is the another tool. Stroom and Spark and Scoop, sorry, Stroom, Spark, Scala, both are combined way of operation. Okay, Stroom is the another interesting tool for similar kind of the MapReduce, but it's a very faster and lighter. Then there is a Spark is the 100 times faster than the MapReduce. Okay, so other tools called Flume, Accumulo, Ambari is just managing the monitoring tool. Atlas, Kafka is another tool. Knox, Mahout is the machine learning tools. To machine automatically to learn. We are writing a program to learn the machine to automatically learn. It's called Mahout. M-A-H-O-U-T, Mahout. So similar way, these tools are available. So whichever the three green is available, that is a majorly used tools. Okay. So these are the tools where you can able to understand. Yeah.
The NIFI, the Apache NIFI is there, right? Apache NIFI.
Where it is?
NIFI, NIFI for real-time data.
Can you type?
Be
Can you type over here the chart window?
Yes.
NIFI, N-I-F-I. I'm not sure about that.
Actually, we are talking here is our organizations is currently doing the scoop activities, but from the top level they are rearranging into the NIFI, Apache NIFI, because we are doing the connected cars big data.
Okay.
So Apache NIFI is reading the real-time data, so we are going for this one also.
So you are using for connecting to the databases.
Yeah, the connected cars. We are doing connected cars. So currently we are collecting data and transferring to the scoop only. But the Apache NIFI is for real-time data. So we are planning for the Apache NIFI also.
Okay. So, but it's never the Apache or maybe Hadoop environment will not call it as a real-time data, but it's a near real-time data always. Even though it's one minute before, it's a historical data. Okay. So you can call it as a near real-time, but it's not always a real-time.
Yeah. So in case whenever you have time, please check this one also, so that we will discuss that.
Okay. So similar way, there are hundreds of tools are available in the sub-projects. You can go through that. The Hadoop environment, if you put the Apache, we majorly specialized on the top tools where across the global people are using. Okay, so into the big data, if you go there, you can find that entire tool. Okay, so that's where we want to understand these tools where we study. Okay, some of the Falcon and outcome low. Okay, you can see that. Okay, so here you can able to understand this Apache Flume. It's every tool is used for different purpose. Okay, all the tools are used for distributed data processing on your distributed data processing tools. Each tool is used for different purpose. Okay, Apache Flume is used for different. Scoop is to import, and the MapReduce is used for different. Then there are Crescent are used for different purpose. Spark is used for different purpose. So each value, each things will be used for different purpose of your tools. Some of the time you might be using for visualization of your tools. Okay, if you want a data visualization, you have to use a tool called Tableau. That Tableau is one of the major tools currently widely used in the big data field. Tableau. Okay, this Tableau is one of the major software where you can able to you have to first stage you have to cross the understanding of the Hadoop, HBase, Hive, Pig, Scoop, Spark, all these things, programming stuff you have to understand first. Then you can go through the next level of stages going towards on the Tableau. Okay, this Tableau is one of the major tools widely used for visualization of your data. Okay, this is another tool. This is also separate training is available, but you can whenever the training schedule is there, you can join over there. But first thing you have to understand on the these tools, the programming level. On a programming level, you have to understand this. First thing you have to study on the Apache Hadoop. So whatever I am teaching here, just a webinar session, just like a less than a foundation level. Okay, but there are intermediate level, expert level of programming. That's so many projects, so many live examples, so many programming syntaxes need to be used for in this particular environment where you can able to do the coding on your Unix command. So there are 502 different commands are available, 500 statements you can learn through that. So each syntax you can learn, and then based on that you can do the real-time examples on that. So apply that, then only you can gain the knowledge. Okay, that's where we are working on that, on towards of that. So this lab facility will provide for each and every training people. This lab sessions will be provided. Lab will be given for a working model. Also, they will install into the all the software bundles will be provided into your computer. So major thing is you have to study through HDFS and MapReduce and Yarn. Then you have to focus on your Pig, Hive and HBase. Then Scoob you have to study. Then Uzi. Then you have to study the Spark. So these areas you have to cover on this to become a Hadoop developer. So each software will have its own syntax, its own coding methodology. It has its own project approach. So each tool need to be learned to high level, to intermediate, to foundation, intermediate and expert level. Then only you can sustain on this field for a very long time. That's the right approach of learning. After this learning, then you can move to the, there is a separate model of learning on the Spark and Scala. Okay, then we have to two words on the Spark and Scala field or Kafka field. So Spark and Scala is the another field of 2 days to 3 days of training program that you can able to understand after the foundation training or intermediate training is completed as a Hadoop developer. So then there is a data scientist program model. If you are just understand about the various programs where you can able to uh, how you have to approach your big data learning. First thing is you have to go through this Hadoop certification model. So then if you want to become a data scientist, okay, there is a data scientist program model is there. That model is a totally different. So Apache Spark is the separate training program. That is a high level into separate programming. You have to you have to choose the path into Java or Python. So either one language you can choose to learn through that, and then you can do the big data programs. Okay. Then there is another certification called Hadoop Administrator. This Hadoop Administrator where you can able to do the, you can choose your career path as an administrator, system administrator kind of way. You can manage the very large systems of computers. And there is a other things there on the Spark and Stro separate sessions are there. And if you want to become a data scientist, you have to come through this Hadoop developer, and then there are other data science with R programming, and then there are data science with the Python programming. There are so many other advanced tools will be combined over there on this particular subject knowledge. Okay, each program will be driven by the expert on this particular field. They will teach you on that on this particular topic. Okay, so that's all about the how to approach on this particular field on this stuff. So now we'll move back to understand learning many other things. Okay, so there are certain basic commands you can understand, and then you can go through that to use the what is the user they are using. You just use this command called Apache user directory. What are the user directory? You can just understand about this, which current user directory. One second. I'm getting a call. Okay, hey, I'm back. Okay, so first thing is what you have to do. So you have to set up a lab like this. So what you have to do, you have to just use the menu command. First thing, before learning to Hadoop, you need to understand about the Linux command. Okay, there are hundreds of Linux commands you have to normally use. From the list to all the commands you can use the commands what the Linux command. You just simply type over there in the google.com. And then but in the training material you have with the simple examples you'll get. But for your understanding, you can just put the command Linux command. Okay, so just you can see what is a ch directory, what is a chmod. So these are the different commands where you can able to actually understand and learn on this particular command field. But for a training material, everything will be get covered. But for your understanding, you can take your own benefit on learning this command, on how to operate the various different commands to use on the this each and everything. What is the apt-get? What is the cat function? What is CD? What is chmod? Cron job, CMD, core. So these are the various different tools of Linux command. It's very important to learn this command to before moving to become a Hadoop developer. So in this environment, you have to go to with the commands, whatever we are trying to use. First thing is you have to go to on a Linux command. So you have to first learn the Linux command on this environment. Then you have to come back to the Hadoop commands. Here we specified all the Hadoop command, right? So each and every Hadoop command, this is a webinar slide, okay? But in the actual training, there are hundreds of program syntax will be provided. So it's a practical oriented stuff will be covered over there. That you can learn through end to end. But here in the foundation level, you can still learn that of basic commands where you can able to just like a kickstarting your learnings. Okay, so similar way you can just put your commands over there into the Hadoop environment. There you can learn certain things. Let's do some examples also. So before that, you have to understand certain other things. What is the HDFS architecture? Okay, HDFS architecture is the collections of node where it will put together into rack. Rack is the 16 combination of computer is called one rack. 16 data node is called one rack. And then other packet is the name node and data node we already saw. Okay, it's a grouping of data center. The data center might be look like this. Okay, I'll show you that data center. Data center. Okay, the data center might be look like a big computers. Racks will be there. Each rack will be specified into multiple racks computer, where the clusters of computers are managed over here. Okay, so this is called clusters of computers. So when you want to design a different data servers or racks, all those things, you can just see there how these structures of 16 computers are specified into a rack model. So this is how the big companies and all maintaining their servers. From there we are just connecting from to the server. So it need to be maintained in a AC room. There is a separate ITL infrastructure model you have to focus for creating a data center. Okay. So this is how the servers or clusters will be work. Okay. So how to install the Hadoop into your system? First you have to try to install the Ubuntu. Also you can install the other software. I install in my machine latest Ubuntu 17 version. But here you can just choose the alongside of your Windows. So Windows 7 as well as the Ubuntu that you can choose. Once you choose that, you can choose the step-by-step guidelines. You can choose the first Ubuntu or Windows 7. Choose the Ubuntu, then you can log in. Once you log in that, you will have a terminal window. So in the terminal window, there is our there is a Hadoop installation guide is available on your meetup.com under the file sections. You can go through that for how to install the Hadoop, how to configure that. So there you can see the step-by-step guidelines for your Hadoop under the file section. Hadoop installation guide. Okay, so here you can find the step-by-step guidelines of your Hadoop environment. But the training will provide entire software dump, software installation, all these things on your laptop and also cloud. All these things will provide. But you can go through that how to install the how to install the guidelines. Okay. Second thing is you have to understand the next. You can also install into the Windows environment by creating a virtual machine. Certain computer will accept this virtual machine. Certain computer will not accept this virtual machine. So be careful before installing this virtual machine. So here you can dump the ISO file. From the ISO file, you can create a virtual machine on top of your existing machine. Okay. There are several of hundreds of concept is there on the MapReduce. In the MapReduce, it is containing the partitioning, and then there is a combiner, sorter, shuffler, all those things is there. That need to be worked in the practical manner. So those is just a high-level concept of how to use the reducer, how to do the combiner, all these things that you can go through. So there are different file formats available. So when you're writing a MapReduce program, I told you it will accept the structured data, unstructured data, and semi-structured data. So here the format, how it is accepting is there is a format of each file system, like a file input format. There is text input file format, text input format. Other format is key value text input format. Another format, if you are adding a video file or audio file, then you have to use the command called sequential file input format. Other format is sequential file as text input format. Okay, so these are the various input file format where you can use this syntax, this command for on your Java program. Okay, it can define your input file format, file input format, file text input file format, key value text input format, sequential file input format, sequential file as the text input format. These are the different input file formats are available in the standard MapReduce program. Okay, so other stuff is the Hadoop, the data variable what you're defining here, integer, long, float, double, text and all. Here you have to call it as an int writable, long writable, float writable, double writable, text writable. All these things you have to. It's a writable format. These are the different classes. For writing a MapReduce program, you have to create a 3 different program. One is the driver, another is a mapper, another is a reducer. 3 different programs you have to write for writing a one single concept. Okay, if you apply a business logic, you have to create a driver file and mapper file and reducer file for writing a first Java program on your Hadoop. Okay, so here some of the examples of writing the word count program. How to write a giving a input file format. So here the input file format, you can see what is the this driver file is the what is the flow of your project, what is the flow of your particular value. So file input format, send input path, file output format. So these are the commands used with the Java coding. So here we are importing the Hadoop libraries. This library will be compiled in your Hadoop environment. Once it is done, there is a map reduce engine will execute this program where this each data block packet will be converted into the key comma value pair and it will be get processed the very large data. So this business logic can be applied into 1 terabyte of data, 10 terabyte of data, 1 petabyte of data also, but it will work very fast when you are processing through map reduce engine. That's the main concept. So here we explained all this line by line of commanding, a syntax, how to use. If it doesn't know the Java also, you can able to understand these programs by step writing the each and every line of index on this particular full-fledged training program. Okay, but you can able to understand high level over here on this webinar sessions. So the naming of the job. Job is the one of the job name what you have to give as the what program you are writing. That's called set job name. Then you have to specify input and output path where you have to specify what is your input file format that you have to pass as a command line argument. Okay. Other thing is output format. Either output format can be text output format. There are other set of output file formats are available. How we saw about the input file format. Similar way, it can be text output, it can be other output format. There are so many different output formats are available. Okay. The next one is mapper file. This mapper file you are applying your business logic. What kind of the business logic you are going to apply for that particular data? What kind of the mapping value you are going to do is the mapper. So here the logic is word count program. The word count program will be splitting the multiple word where the white space is available. Each word will be converted into a one word. So that is a mapper. So each word will have a key and value. So out inside the 64 MB block, all the data will be converted into another level of key comma value pair. Each word will be converted to key and then there is a value. Each key will be combined with the another key of another block. So each word will be combined with the another word. So this is the mapper method. Then the reducer program, it's applying the business logic where it is applying the final result where it need to be collect the output from the previous processing. Then it need to write as the int writable. So it is a writing the Hadoop command in the writing format. So these are the scripting language you have to understand and writing has become a Hadoop programmer. Similar way we will write a 10 20 plus program for each and every sessions of the program oriented. So I will explain each and every line by line of statement so that you can able to understand. So there are lots and lots of concepts available in the Hadoop MapReduce. There is a combiner is there. How the combiner we have to use or reducer we have to use. There are hundreds of lines of command is available for the combiner. What are the logic we have to apply for when we are combining various different input format or output format. This combiner, the intermediate data. So this is how the intermediate data will work on the word count program. There is a partitioning is available on this particular field on the key comma value pair. This partitioning divided into multiple key spaces. So each key comma value pair will be partitioned into that will have the multiple partition. It will be has the hash partitioner. Okay, this hash partitioner will work very faster on partitioning this data into multiple key comma value pair and it will combine. it will compare. There is sorting mechanisms available on the data processing on the MapReduce engine. Key comma value pair, it will sort and shuffle. Based on that, it will work. There are secondary sort is available. We'll understand about more on that. There are indexing available onto the data packets. So when any data processing is performing from the one node to another node, so there is a multiple mapper will be combined into multiple other mapper data block. So like here page A, page B. So that page A is 64 MB sub block and page B is another 64 MB sub block. That page block will be get combined with the other blocks. Okay. So another thing is you have to understand Hadoop structure, Hadoop ecosystem. So these are the major tools normally global level people are using. What is the HDFS? That's a Hadoop distributed file system. Normally any data processing is need to be used on Hadoop. This layer need to be used for your storing your data. And then MapReduce engine is on top of your HDFS. These two engines are Hadoop software. All other tool HBase or column fashion oriented database tool. Hive is the SQL query language tool. Or Connector is a statistical tool. Mahout is a machine learning tool. Peak is the scripting language tool. Oozy is the workflow tool. And the Zookeeper is a coordinator tool. And then you have the Flume and Scoob is the other tools. So these are the common tools for your understanding. So today we'll go through certain topics. We have next 15 minutes is there. We'll understand what topic we plan. We studied for Hive, right? We'll go to Hive now. Or we'll continue the pick for today. Okay, let's, because very time less is there next 10 minutes, we can cover only certain high level on the pick. Okay, we'll continue over there. Okay, let's today understand about little bit about the pick software. Okay, this pick is one of the Latin script language tool. Okay, this particular tool is one of the Hadoop tool. This particular tool where you can able to write similar to our Java program, but it does not require a Java language. It is a just a normal English language. You can able to write a Hadoop program. This compiler will convert into your normal English program into Hadoop MapReduce program, and then it will execute. Okay. So let's see one by one about the pick. Pick is a platform to process the very large data set that contain high-level language expressing the data analytical program and couple of infrastructure for evaluating this program. Okay, it is a platform for Pig is one of the platform for analyzing the large data set. Okay, it is one of the tool where you can able to process very large data set. Okay, Pig is a abstraction on top of your Hadoop. Pig is one of the tool where it is on top of your Hadoop environment. It will be converted to MapReduce and executed on the Hadoop cluster. Whatever the program you are writing, that will be converted into a MapReduce program and then it will execute. Pig is widely used and accepted and used in the Yahoo website, Twitter, Netflix, all the softwares tool, people are using this Pig. So it has been widely used. Anyone aware of what is the tool used by Facebook? I'll just unmute that for a minute. Can somebody tell that what are the tools are used by which are the companies? Facebook is developed under the which language? Are you there?
PHP.
Facebook is developed under PHP?
Yes.
Okay, all the data where the data are stored and the retrieving all the videos and photos are stored through PHP.
No, Hive.
Yeah. So Facebook is developed under the Hive.
Yes. Database language, to store database, it uses Hive, but in normal, in PHP, like PHP.NET Java, in that way, PHP was developed by, basically used in PHP to simple programming language, but in store databases like Hive.
So it is basically this database used Hive language. It is specially designed for Hive is specially designed for Facebook, but the Facebook used normally on this Hive, but majorly many company you may not aware like a Twitter is using big data different tool. Pig is used by big data Twitter. So when you're
It is
tweeting
used by Yahoo.
yeah, Yahoo also using Yahoo, Netflix. There are hundreds of clients. They are using these big data languages. Each company they are exploring and using different software. Okay, so Pig is one of the major software where you can easily learn very quickly. Also, you can learn this software. So how Pig is working? Pig is just a simple language where you can able to learn very quickly. There's a normal English language. Load file like we are writing a 100 lines program in the Hadoop in Java, right? But here you can write simply 2 lines of code where you can able to execute same word count program into simple 2 lines. But these 2 lines will be converted in a map reduce engine program. Then it will execute to the multiple hundreds of computer. The Pig environment, the extension of file is let us store the file name called .pig file. It is parsing the script into compile into a map-reduce jobs. So these jobs will be executed in the map-reduce engine. This map-reduce engine will be connected with the Hadoop clusters. Each Hadoop clusters will be execute the key comma value pair of the data blocks. How to install the Pig? You have to go to the apache.hadoop. So here apache.hadoop by name. Then go to Pig. Apache Pig. Okay, so under the Pig, you can just go to the download section. Okay, so here Apache 0.16 can download from here. Okay, so this download is available from here. Apache Pig can download of that particular software. Then you can start installing through this configuration. Okay, in the bus RC, you have to specify the home path and then the location of the unzipped file where you are specifying the big directory. So then you have to come to the similar kind of scripting language where you can able to find, if you just type the PIG, it will come that particular language. Okay, so there is a grunt. You can see now grunt. What is a grunt? Is it my voice is not audible? Let's check the audio first. Is it my voice is audible?
Your voice is audible.
Okay,
Your voice is audible. Yeah.
fine. So I somebody typed as my voice is not audible. Rajwell is specified. Okay, fine. So if you want specifically, if you want to go to any software where you can able to use the command, okay, the grunt. Okay, if you want to go to Hive, you can just type Hive to go to the Hive. If you want to go to the HBase, you can just type HBase. It will go to the HBase. If you want to type the Pig, you can just type the Pig. It will go to the particular tool. So this is Hive environment where you can able to use the all the select statement, For example, select star from all these commands you can use over here. Okay. So now we are studying about the pig. I'm just discontinue this. Okay, just type the pig. You will get two different window. One is a grunt. Okay. So we will study about the what is the local mode and then grunt mode. Okay. The first thing is pig can be used in the two different mode. One is the pig-x local, pig-x map reduce model. So if you are normally by default, it is the map reduce model. If you type only the pig. If you specifically type the local mode, you have to specifically type pig-x local. If local, if you are specific, it will work from your hard disk. It will be 3 KB, 3 KB sub block size. If you specify map reduce, then it will work as a 64 MB of data packet. It will refer to the HDFS. If you specify X, you have to specify here where is your file location on your C drive or D drive. If you specify map reduce, then it will be your HDFS location where is your file is available. Okay. So there is a script model, there is a grunt model, and embedded model. So grunt is the interactive shell model where you can able to write the command over there. Okay. But also you can write a scripting. pig.scriptfile.pig, like a Java program, how we are writing, saving the file as a .java. Similar way you can write the program and then write it to pig file. Okay. And then embedded program, you can write you can embed this pig command into your all the Java programs or any of the Java programs you can write this embedded way.
Sir, sorry to interrupt you. One quick question here.
Yeah.
If we run pig in the local mode, right?
Okay.
So does it mean that there will not be any map reduce? So like zero map or zero reducer?
Yes, it will not be work as a map reduce engine.
So when it runs on local mode, it's up to the system that is running on,
Yes,
like whatever Windows are in.
For testing purpose, you can run through the local mode, but actual environment
Okay.
you can run in the map reduce mode.
Okay, thank you. Yep.
Okay, so next thing is we are studying about the what is the need we have to run in the local mode. That's all we need to run in the when we have to run in the local mode, when we have to run in the map reduce mode. Think pick as the Latin script language. It is developed for compile the Latin script. Okay, it's a normal English language command like a C compiler, C++ compiler. Likewise, pig is one of the compiler where it can able to write your program. That program will be converted in a map reduce engine. It is tightly coupled. It's not tightly coupled with the Hadoop cluster because the pig is planned to use for different purpose also. That's why they create as the local mode and then map reduce mode. Okay, they have a different architecture for that. So the local mode will execute in a single JVM. So how the instead of map reduce, the local mode will work under the Java virtual machine mode. So work exclusively with the local file system. Okay, it is why we have to use the local mode? To experimentation, to prototype model, to develop the prototype model or to testing the whether it's working or not, what kind of the way it will work. Instead of very large data set to work on the terabytes or terabytes working or not, the local mode you can just try the simple prototype model of with small data size. Hadoop mode, in the map reduce mode, it will when it is running to the map reduce mode, Hadoop mode, it will run into the map reduce jobs. These jobs will be compiled into the map reduce jobs. So what we done is here, grunt is the, what is that grunt? It's a graphical user interface of shell environment for writing the pig commands. Okay, we'll see about some of the basic commands, but there are hundreds of commands you will run through the training model, but you can understand basic command. So if you have type the pig command, there are basic concepts available. Data types, pig components, field, tuple, bag. These three concepts is very important. Field is the one of the basic field level data type. Tuple is the collections of field. Bag is the collections of tuple. Okay. So the bag is the table in the database. Tuple is the row in a table. Okay. So similar to our relation database, we are just putting the how to store the data in a pig. How to process the data in a pig is here. You can see the different type of environment where you can able to see that what is a pig, what is the one second. So here any data packet you are specifying, it's a field or tuple or bag in a pig. Okay, the data model here field tuple bag is a data block model. So if you want to do a word count program within 2 lines of command, you can able to process. Okay, so here it's a normal language, right? So you can just put the whatever the language you want to write. For example, here record equal. What's the command here? Just specify the load where is the file path. Okay, just you are specifying where load is the keyword. Okay, the file path is the where is the location of your path. Okay, so that path you have to specify. So here we have to define certain path. So that path we have to just put the command test.txt. I'm just typing sample command. So once you done that, you have to define your the text file is containing what is the value. Okay, so this is containing the character array and then the structure here. What is the count? How many counts are available? Okay, so you are defining the structure of that particular data. Okay, here you have to define what is the number of letter, whether it is a character or what is the count. So here the data structure is a comma 1. That you have to define as the another keyword. Then letter character array. Okay, so letter as character array. Then count. Count is the another variable as the integer or what is the int. Okay, here we don't have a text.txt, but if you have created text.txt, what it will do to load the data into your record field. Then there is a keyword called dump the data. Dumping is the display the what is the value in your file. Okay, that is for first command you have to learn as a load command, and second command you have to learn the dump command. So dump is the display the result of the screen, and store is the to typically save the file into your data structure. So dump is the very final result is coming. That final result you can be able to store. Okay, there are hundreds of commands is there in the pig. One by one only we can able to learn. So each and every keyword we'll learn through with the syntax, and then we'll with the model of how these each functions are using an experimental model, how this each and every line by line, each and every keyword by keyword we'll learn through that. For example, you try to create a environment first on your laptop. You create a software, install the software over there. One by one we'll learn on the how to load this data, how to create a file over there, how to run, execute that. So those kind of things we'll learn. So far what we understand today is we understand the big data, we understand the Hadoop, we understand the MapReduce, and we started understanding the what is the master node, what is the data node, and then how the racks are available, how the Hadoop system and Hadoop environment is working, and then what is the Hadoop, then what are the Hadoop subprojects, what is the cloud environment, how to start launching this Hadoop, and then how to start doing the big program. Similarly, just kick-started the very basic foundation level. So there are intermediate and expert level is there. One by one you can learn through that when you're combining the other multiple learning model. Okay, so what we'll do, we'll stop now, and then if you have any question, just post to the WhatsApp or the post to the meetup.com or the bigchapter.com, bigdatachapter.com. Okay, we'll meet soon. Okay. So any other questions you can post it over. Next 5 minutes we'll discuss that question. So then we'll continue over there because this big chapter is taking long more time. We have to deeply understand this concept, inner bag, outer bag, all the how to do the program and the dump, how each statement need to work, all the things we have to understand very deep dively. So we'll see one by one, but basic concept you can try to learn high level. Okay. So any question you can discuss over now, or anybody want to share your knowledge to other people also, you can talk now.
Hello.
Yeah, go ahead.
Sir, one question is that I will start this one using Cloudera or just using Linux.
So best is both are same. Okay, you can use the Linux and install all the open source, or it is a package.
Okay.
Cloudera is just a package. They have taken the open source tool, combined and packaged into one graphical user interface way. It has been packaged in a nice way, Cloudera. But if you want to use the Cloudera, your system need to be very, very high powerful configuration. Minimum 4 GB RAM. You are using enterprise level, 10 GB RAM is need to be there. But otherwise, you can go through the Linux model, download all the open source tool and install one by one. That is the best model.
Okay. Thank you, sir.
Okay. Any other question? Okay, thanks all for joining. So we have the training program on the 23rd and 29th and 30 and 1st. Anybody want to join? There is some post registration slot is available. You can join over there through the Google form, which is already published in the meetup session. Thank you for all for joining. We'll meet up on the next week session. Thank you all.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Keep learning and keep sharing. Okay.